Hello folks, this is a video for Chapter 6 recap, or a really good kind of brief video to watch before your test to kind of remind you some things after you have already gone through the study guide. So things to note, your test is going to be 18 questions total. 18 questions total. Specifically, it's going to be 10 multiple choice and 8 free response. Now, I am going to make the point values a little bit different. So for those 10 multiple choice questions, those are going to be worth 4 points each for a total of 40. And the 8 free response questions will be worth 5 points each for a total of 40. So the entire test will be out of 80. Okay, so the multiple choice section and the free response section are worth the same amount of points total. Okay, so this is just going to kind of talk about some topics that I feel like you really need to make sure that you remember, pay attention to, and maybe put forth a little more effort to learning deeper before your test. The first thing that I want to address is that radians don't always, well, maybe I should capitalize don't. Radians don't always include pi. So I know many times radians have pi in it, right? Like 3 pi over 4 radians, but that is not always the case. So I'm going to do a couple of examples that seem to give some or cause a little bit of confusion, I'll say, on your study guide. So first problem that I'll do here, I'd like to make this font bigger if possible. There we go. Okay, as it'll say converts the following from radians to the nearest degree. And if I give you, let's say, the number 5. So if I want to convert the number 5 to the nearest degree, again, this is a great example of a number, literally just 5, that stands for radians that doesn't have pi on it. So if I want to convert that to the nearest degree, I'm still going to do what I would normally do, even if my radians did have pi. And that's multiplied this radian of 5 times 180 over pi. And if you type this in your calculator, you have to make sure that you put this fraction in parentheses, or else your calculator is going to multiply 5 times 180 first and then divide by pi. So if you plug this into the nearest degree, you should get about 286 degrees there. Another example that seemed to cause some confusion was if I asked you to, say, change 117 degrees to radians to the nearest whole number. So this is going backwards. I'm giving you a degree now, and I want you to convert it to radians. So instead of multiplying by 180 over pi, we're going to multiply 117 by degrees by pi over 180. And then if you put this over 1, we multiply straight across, right? So that's 117 pi, over 180. And then if you reduce this in your calculator, you'd get 13 pi over 20. And people are like, well, how do you round that to the nearest whole number? Well, actually, literally divide this in your calculator. If you divide this in the calculator, then it's going to give you a decimal, which is going to allow you to round to the nearest whole number. And if you do that, you should get about 2 radians. If it helps you to feel better, anytime you put radians, you can put rad after it. That's not necessarily mathematically correct. You don't usually see that in context. We understand if something is radians. Oh, excuse me. It's kind of late right now. But if it makes you feel better to know that you're putting units on there, I'm fine by that. Okay, other things to know. So that's your basics with degree and radians. You need to know the following formulas. Okay, so you need to, I hate to use the word memorize, but it's the truth. If you don't know it, you need to make sure you can generate it. Arc length, dealing with a circle. Okay, arc length is S is equal to R theta. You also need to make sure that you know the area of a sector, which is A equals 1/2 R squared theta. You also need to make sure you understand angular velocity and know that its formula is omega equals theta over t. And then lastly, linear velocity, which is v equals r times theta over t. But remember, we said theta over t is angular velocity from omega. So another way you can write this is just r times omega. Okay, for these, after you memorize the four, that's great, but you also need to make sure that you understand that theta must be in radians. Okay, so many of these problems, I give you degrees, and when you plug them in, you have to make sure you convert them to radians first, or I might ask you to go backwards. Maybe I give you the area of a sector, but then I ask for the angle in degrees. So after you find your answer, you have to convert it. Okay, so when you use these four formulas or five formulas, theta in these cases is always referring to your angle in radians. Okay, also angular velocity, your answer will be in velocity is like speed, right? So it'll be radians per whatever amount of time. Linear velocity is going to be more so like miles per minute or inches per second, stuff like that. So let's do a couple of examples of where these would come into play. I may ask you to, let's see, find the degree measure of a central angle associated with an arc that is 11 centimeters long in a circle with a radius of 9 centimeters. So the key word in this phrase is 11 centimeters long. That lets us know that we are dealing with arc length. Okay, so I know I'm dealing with S equals R theta. So then it says find the degree measure of the central angle associated with the arc that is 11 centimeters long. So that's going to be S, right? So that'll be 11 equals, I know that the radius is 9, and I'm solving for the central angle. I'm solving for theta. So if I'm going to get theta by itself, I'm going to divide both sides by 9, which implies that theta is going to be approximately 1.2. But remember what I said earlier, theta, anytime you do these, this is your answer in radians. So if I want that into degrees, once you get your final answer, you need to convert this to radians by multiplying by 180 over pi. Again, make sure you put 180 over pi in parentheses when you convert, and you should get that it's approximately 70 degrees. Please be cautious, guys, especially on multiple choice questions, because guess what? 1.2 might be an answer choice. So you might, write that down as your answer, bubble that in, and not even think twice about it. But just be cautious, paying attention to your radians versus degrees. Okay, let's do another one. So you find the area of a sector if the central angle measures 75 degrees and the radius of a circle is 7.6 millimeters. So I've got area of a sector, which means we're dealing with A is equal to 1/2 r squared times theta. It says central angle measures 75 degrees, radius is 7.6. So I know angles or areas what I'm looking for. 1/2, I know that the radius is 7.6, so that'll be pretty easy, 7.6 squared. But don't make the mistake of plugging in 75 for angle theta, because theta requires that it is in radians. So you're going to take 75, you need to convert this to radians first. So we're going to multiply 75 by pi over 180. And then if you wanted, you could get a decimal. But if you get the decimal, you need to leave that decimal in your calculator for as long as possible. Okay, my other recommendation is just simplify this, right? 5 pi over 12. And now that this is in radians, then I can come over here to my formula and put 5 pi over 12. And then I can just put this whole thing in my calculator and get the angle, or get the area of a sector, and I didn't say how to round, just do nearest tenth for now. And I would have only rounded once. You should get about 37.8. I'm dealing with area, millimeters squared. Again, on your test, make sure you pay very close attention to your units because you will get points off if you don't have the correct units. Okay, we also had angular velocity and linear velocity issues. So let's say, what is angular velocity? Of 312 revolutions in 8 minutes to the nearest tenth. Okay, I'm looking for angular velocity. So again, you need to be able to spit up the formula for that. Omega equals theta over t. So it says, what is the angular velocity? So I'm looking for omega. And it says 312 revolutions in 8 minutes to the nearest tenth. So I know t is 8, but the issue is 312 is not theta. Theta, in this case, stands for an angle. Particularly, it stands for the angular displacement that occurred when the wheel, or whatever the circle is, was rotated. So that's where the 312 revolutions come into play. The angular displacement is we're gonna take those 312 revolutions, multiply it by 2 pi, because that's the measure of one revolution, which will be 624 pi. So then again, that's something that you could get it as a decimal, but if you leave it in terms of pi, you'll get a more exact answer. So then if I do 624 pi in as my theta divided by, so remember this is in radians, and then t is time, so it's going to be 8 minutes. If I divide this, I asked you for the nearest tenth, then that means omega will be approximately 245 units will be radians per minute. And in this case, when you have to write units for your answer, you definitely do want to put at least RAD, if not spelling out the whole number radian, so that I know your units there. Okay, the next thing I want to discuss is this idea of a period. So remember with these trig functions, the word period just means what is the length of one cycle. So if I give you an example, I'm going to draw a little figure here. Okay, let's count by twos. All right, if I have this drawing, let's say it starts at 0, 0. Okay, and it maybe looks like this. So my first question is this periodic? And then we can keep going. Is it periodic? Does it repeat itself over and over and over and over again? The answer is yes. Not exactly, right? Like if you look at these as little mountains, I have some small mountains and some big mountains, but I do have repeating parts. So your job is to figure out, okay, well, how long does it take for it to repeat itself? So I think some of you are confusing period with maybe where it crosses the x-intercept again, and you might say that the period is 4. And you would be blatantly wrong, because that is false. Okay, the period is the length of one cycle. So what your job is to go through and figure out, okay, where does my figuration start repeating itself? So if I start at the origin, I have a little mountain and I have a big mountain. Well, at 8, notice it starts repeating itself again. I have a little mountain from 8 to 12, and then the big mountain from 12 to 14, and then it repeats over and over and over. So this length is 8. Perhaps you see it differently. Perhaps you started at 12, and you said, okay, I've got a big mountain at 12, and then I've got a smaller mountain from 16 to, it should be 18. No, 12, 14, no, I'm lying, 16, and it should be at 20. So then from 16 to 20, I have another mountain. So even though I did this one, I did big mountain, then little mountain, that is still from 12 to 20, a displacement of 8. So in this case, your period, no matter which way you look at it, even if you started here at 8, it would take all the way until you get to 16 for these two mountains to repeat themselves. So the period in this case would be 8. It's the distance between the cycle starting all over again. Okay, so now again, that leads me into trig functions. If I have y equals a times the sine of k theta plus c plus h. Let's talk about all of our variables here. A stands for amplitude. Amplitude. So remember, amplitude is, it tells us basically how much your function stretches from the midline. So in this case, our midline is the x-axis. Amplitude would be this length here, from the midline to the maxes and the mins. So all of those would be our amplitude values. K doesn't tell us, it's not something specific and say, oh, K stands for this. K helps us with the period. Okay, the period is found by doing 2 pi over k. So k in and of itself is not an answer to something. You use it to help you find the period. Theta obviously is our angle. C also in and of itself does not help you find anything. Or sorry, I said that wrong. It does not tell us something off the bat. It does, however, help us find the phase shift, which the phase shift is found by doing negative c over k, and then h blatantly tells us the vertical shift. There's nothing to figure out. Okay, so I may ask you to, let's see, I don't know what number I'm on now, I lost it. Number 6. I may ask you to write a cosine function with an amplitude of 5, a period of, I'll write it in here, a period of pi. Oh, we're back to small font. Great. A period of pi, and there's number 7, great, and a phase shift of, let's do 3 pi over 8 to the right. 3 pi over 8 to the right. Okay, so the only easy part about this is amplitude. We know that our amplitude is going to be, hopefully you remember, plus or minus 5. Okay, now the other thing is period is pi, but that does not stand for one variable. Period is found by computing 2 pi over k. So what that tells us is if they tell us the period is pi, then this means that pi equals 2 pi over k. And then I can solve for k. So then if I put the left side over 1 and cross multiply, that implies that pi times k, or just pi k, equals 2 pi. And then if I'm trying to solve for k to plug that in my formula, divide both sides by pi, it cancels on both sides, giving us the value for k, which is 2. So there's one variable. And then lastly, the phase shift of 3 pi over 8 to the right. Again, that's not just a variable that you can plug in and be done and say, ooh, c is 3 pi over 8. That is not true. C is not 3 pi over 8. Remember, phase shift is found by doing a computation. So if we say that phase shift is equal to negative c over k, well, they tell us phase shift is 3 pi over 8 is equal to, we don't know what c is, but you just found k up here. So that'll be negative c over 2. And then if I cross multiply again, I can solve for c. So 3 pi times 2 is 6 pi equals 8 times negative c is negative 8c. And then if I divide both sides by negative 8, then that gives me c is equal to negative 6 pi over 8, which should reduce to negative 3 pi over 4. So this is the value for c, not 3 pi over 8. So then if you use this, I'll say, this general form here of those trig functions, and plug in your variables. Notice we did not have any information on a vertical shift. So if you plug in these three variables, then you should end up with your final answer, y equals plus or minus 5. We're dealing with a cosine function, so times the cosine of, it's going to be k theta. K is 2 theta. And then it's going to be plus c, but c is negative 3 pi over 4. And then there is no h value, so that's 0. So there's that. Okay, the last thing I want to discuss is the short video that you watched yesterday. It's all about trig inverses. Trig inverses. And basically, graphically, the things you need to remember is that literally your x and your y axis switch, right? Because we flip the domain and the range. In your calculator, if you ever need to graph arc sine, arc cosine, arc tangent, you're going to have to use the second button. So you have to remember that if you have arc sine and you want to see what that looks like, you're actually going to graph sine inverse. And in your calculator, you would hit second sine to type that in. And the same goes for these. Arc cosine is going to be cosine inverse. Arc tangent is going to be tangent inverse. Now you also have to remember that the inverse trig functions are not, the inverse trig functions are not functions themselves. So if you graph it in the calculator, you're only going to see one period of it, because if you do more periods, then it becomes not a function because it fails the vertical line test. Okay, algebraically, I want you to remember all we got to do is switch x and y and solve. So maybe I ask you to, let's say, find the inverse of the function y equals 3 plus the tangent of 5x. So if I want the inverse of this, first thing we're going to do is switch our x and y. X equals 3 plus the tangent of 5y. And then I want to get y by itself. So the thing to do is that we need to first isolate our trig function. So if I want to isolate that, I need to subtract 3 from both sides. So then I get x minus 3 equals the tangent of 5y. So if I'm trying to get y by itself right now, it is stuck inside of tangent. So I'm going to use the opposite of the tangent function, which is tangent inverse or arctangent. So then if I take the tangent inverse of both sides, on the left side I have the tangent inverse of the entire side, x minus 3. And then on the right side, tangent inverse of tangent cancels, leaving me just with 5y. And then if I want to isolate y, I can divide both sides by 5. And then I end up with, typically you won't see it being divided by like that. We'll actually just write it as a fraction. So you could have y equals 1/5 times tangent inverse of x minus 3, or you might see it written as, and you could also, if you wish, write it as 1/5 times the arctangent, which is all one word. It looks kind of weird that I wrote it like that, sorry. Arctangent of x minus 3. So this was a relatively short video to cover an entire chapter of some things that I think you should make sure that you focus a little bit on tomorrow before your test.